All right, so we're going to be looking at systems of three variables today, but before we get started on that, I wanted to talk about systems of two variables first. We're going to move fairly quickly through this because this should be review. But let's start with this system here of two variables, and let's just quickly talk about the different ways we would solve these, right? We had the elimination method of solving this system, and we also had substitution method, and we're going to do each one real quickly. Now, if you remember in the elimination method, the goal was to multiply one or both equations by something so that when you add the equations together, they cancel out. So if we look at my two equations, 3x minus y equals 7, and 2x plus 3y equals 1, we multiply the top one by 3 and leave the bottom one the same, multiply it by 1. I get new equations of 9x minus 3y equals 21, and my other equation stays the same. I get 2x plus 3y equals 1. And when I add these together, notice that the y's cancel out, right? So the goal in the elimination method is that when you add them together, the one variable cancels out, which in this case is y. So now I can solve for this equation, and I get x equals 2. And then to solve for y, I could plug it back into either one of those equations. If I plug it into the first one, I get 3 times 2 minus y equals 7. And we can see that y equals -1, so my solution is 2, -1. So that was the elimination method, multiplying one or both equations by something to get a variable eliminated when we add them. In substitution method, if you remember, let me write out these again. 3x plus y equals 7. 2x plus 3y equals 1. The goal was to solve for one of the two variables. So I'm going to take a look at this top one. I notice I already have a minus 1y. So if I solve for y, I get y equals 3x minus 7. So I solved for y in one of these. And what I'm going to do now is take my second equation, the 2x plus 3y equals 1, and I'm going to substitute in the 3x minus 7 in for y. So I'm going to do this. I'm going to pull in the 3x minus 7 from up here. And now I have an equation of only one variable. If I simplify this, plus 9x minus 21 equals 1. I get the same thing. I get 11x equals 22, or x equals 2. And you can see we get the same thing again, and you would take that to here, plug it back in to this up here, and solve for y, and you'll see you get y equals -1, okay? So that was a quick review of elimination and substitution. If you need to pause it and think about it, or maybe redo it on your own a little slower, feel free to do so. But again, since that is review, and that's not really the main focus today, I want to focus on systems of three variables. I'm going to jump right to that. So if you go to the next page, notice now we have a system with three variables, x, y, and z, okay? If we try to eliminate the variables like we did last time, we're still going to be left with 2, and so you're going to see what's going to happen here when we try to do that. So we're going to solve this system of three variables using the elimination method. So here's what I'm going to do. I'm going to take my first two equations. I'm actually going to label these 1, 2, and 3. What I'm going to do is just take my two equations and line them up right underneath each other. Okay? So 2x plus 5y plus 2z equals -38, and 3x minus 2y plus 4z equaling 17. Now notice I can't eliminate two variables at once, but what I can do is eliminate one of the two variables. Okay, so this is equation 1, this is equation 2, right? If I multiply, let's say I want to get rid of the z's here. If I multiply the top equation by -2, and I leave the bottom one the same, multiply by 1, I can actually eliminate my z's much like I did in the system before. So let's see what happens when we do that. Let's multiply that number 1 equation by negative 2. So that gives me negative 4x minus 10y minus 4z equals 76. And the bottom one stays the same, so that's 3x minus 2y plus 4z equaling 17. And I'm going to add these together, and I get negative x minus 12y equaling 93. Okay, so I'm going to call that my new equation 1. Now the problem is, right, I still have 2 variables, right? It can't solve this equation yet. I have 2 variables. So what am I going to do? I'm actually going to do elimination again. I'm going to choose 2 separate equations above, or a different combination from the equations above, and try to eliminate z again, such that I get a second equation with just x's and y's, and then I should be able to solve that system. So let's do this. Let's choose equation 1 from above again. So let's do the 2x plus 5y, okay, plus 2z equals negative 38. And let's choose equation 3. We can't choose equation 2. We already did that. So let's choose equation 3, which is negative 6x plus y minus 7z equals negative 12. And I want to eliminate the z's. So the easiest way to do that is to multiply the top equation by 7 and the bottom equation by 2. And add those new equations together to eliminate the z's. So if I do that to the top, I get 14x plus 35y plus 14z equals negative 266. You can use a calculator on this one, by all means, to do the arithmetic, because the numbers do get a little big. So use a calculator where needed. Then I do the bottom one. I get negative 12x plus 2y minus 14z equals negative 24. And if I add these two together, I get 2x plus 37y equals negative 290. And that's my second new equation. And so now when you look at it, now I just have a system with 2 variables. So you may have guessed it. What are we going to do next? We're actually going to solve this system. So we're going to take the new number 1, which is negative x minus 12y equaling 93. And we're going to take the second new equation, which is 2x. Oops, let me use black. Which is 2x plus 37y equaling negative 290. And we're going to solve that just like normal, just like we did on the last page. I think substitution might be the easier of the 2 methods because we have that negative x on the top. So if I actually solve this for x, we get x equals negative 12y minus 93. And so what we're going to do is take my second equation, which is the 2x plus 37y equals negative 290, and plug that in, right? So we're going to do 2x plus 37, oh, sorry, it's not the 2x, it's 2 times negative 12y minus 93 plus 37y equaling negative 290. Again, I took that 12y minus 93 and plugged it in for x using substitution. So if I simplify this, I get, little problem here with the app. There we go. So now we're going to solve this. So we get negative 24y minus 186 plus 37y equals negative 290. Again, use a calculator where you need it. If I combine all my y's, I get 13y equaling negative 104. And I get y equaling negative 8. Nice job. Now to solve for x, I'm going to take that y and plug it back in to this equation up here to solve for y. So to solve for x, excuse me. So x equals negative 12 times negative 8 minus 93. Negative 12 times negative 8 is 96, so 96 minus 93 is 3. So far, I've got x equaling 3, I've got y equaling negative 8. To solve for z, all we're going to do is take those new x's and y's and plug them back into one of those equations above. It seems to have disappeared, but that's okay. So let's do that. Let's plug it in. So we are going to plug in. You can choose any of the three equations. Let's plug it into the second one. So we're going to do 3 times 3 minus 2 times negative 8 plus 4z equaling 17. Then we get 25 plus 4z equals 17, 4z equaling negative 8, or z equals negative 2. And so we get a total of x equaling 3, y equaling negative 8, and z equaling negative 2. Okay? So again, to kind of repeat what we've done, all we've done here is just basically use elimination twice. We used it above here, right, to eliminate my z's, and then I used it again, or I used substitution again to eliminate my y's, and then that helped me solve, or to eliminate my x's, excuse me. It allowed me to solve for y, and so on, okay? So if you look at the next problem now, solve the system. It says using substitution. Okay, using substitution here. Much like we used elimination to eliminate two of the variables, we're going to use substitution to eliminate two of the variables. So the key here is looking at, all right, which of those equations would be best used to solve for one of the variables? Would it be equation 1? Would it be equation 2 or equation 3? Since equation 2 has the x already singled out, that looks like to be the easiest one. So I'm going to actually solve for x and say x equals 14 plus 5z minus 3y. Okay. And what we're going to do is we're going to replace x in equations 1 and 3 with 14 plus 5z minus 3y and solve those out. So let's do that together, and then I'm going to let you finish it on your own. So we're going to take equation 1, which is a 3x minus 2y plus 4z equal 1, and plug this guy in. So let's do that. Let's do 3 times, and I'll just switch colors so we can see, 14 plus 5z minus 3y. Okay, minus 2y plus 4z equals 1. Now be very careful when you simplify this, because even a simple addition error can really screw up everything. We get 42 plus 15z minus 9y minus 2y plus 4z equals 1. And then I get negative 11y plus 19z equals negative 41. That's my new equation 1, just like we had in the last problem. It's going to be my new equation 1. So when I solve an equation of two variables next, that's the one I'm going to use. So now let's use equation 3 and plug in 14 plus 5z minus 3y again. So we're going to get 4, and then in parentheses, we're going to have 14 plus 5z minus 3y minus 4y plus 3z equals 1. Again, remember, all I did was replace that x with something we know x is equivalent to, which is 14 plus 5z minus 3y. If I simplify this, again, use a calculator where you need it. We have 56 plus 20z minus 12y minus 4y plus 3z equaling 1. And if I combine that, I get negative 16y plus 23z equaling negative 55. And that's my new equation 2. So if I were to write these out and think of this as a separate new system, I would have one equation of negative 11y plus 19z equaling negative 41, and then I would have negative 16y plus 23z equaling negative 55. And we have to use either substitution or elimination from here to solve for y and z. I'm going to let you finish this on your own. The numbers here are a little tricky. The final answers will work out to nice whole numbers, but to get there, it's a little bit tricky. So to give you a hint, I would use elimination, and I would eliminate the y's, and I would eliminate the y's by multiplying the top equation by 16 and the bottom equation by negative 11. And again, use a calculator to help you out. I promise you all the numbers are going to cancel out easily, but this first step, when you multiply everything together, you're going to get some large numbers. But again, use a calculator to help you out. On the test, you'll either have a calculator or I will give you some much easier numbers to work with. So use elimination to solve for y and z there, and then once you solve for y and z, plug those back into one of the three original equations, right? One of these three up here. Once you have y and z to solve for x, and just so you feel comfortable at the end, I will tell you the answers here that you should get at the very, very end. You should get x equals 3, y equals 2, and z equals negative 1. See if you can finish that up, though, on your own. This is kind of the intro, so when we come in tomorrow, we kind of have an idea of what it is we're doing, and we can use these in our quadratics unit. You may say, what's the connection with the quadratics in this? We'll see that our next class. But for now, if you can just understand the basics of systems of 3 variables, that's going to go a long way towards what we do in class. All right, thanks. Good luck.